We're going to take a look at part 3 of section 9.2. And if you're watching this video, I'm assuming you've already done several things. Otherwise, you want to stop the video and go back and finish these items. The first is to work through the Pythagorean theorem practice problems. And that was 10 total questions. There were 5 on the front and 5 on the back. It was a PDF file that I uploaded to my website, and I also added to Teams. And I asked you to do 1 through 4. You didn't have to do number 5 on the front, and same thing on the back. So coming through this, you should have already worked through those problems. And the second thing you were supposed to do before coming here was you were then supposed to watch the YouTube videos, part 1 and part 2 for section 9.2. And those 2 videos walked you through the 2 new types of special triangles. One's called a 30-60-90 and one's called a 45-45-90. So if you've not already gone through those, these problems are not going to make any sense. So you'll want to stop the video, go back, finish the PDF file, watch parts 1 and 2, and then come back here. So if you are continuing, then I'm assuming you've already seen those 3 items, the paper and the 2 lessons on YouTube. And so we're going to work through several examples here, 6 in total, and they're going to get progressively harder as we work through them. So what I have you do at different stages is pause the video, copy the problems down, and attempt to work through them. So keep in mind, this is going to use the 30-60-90 and the 45-45-90 information from the first 2 videos. So hopefully you jotted that down somewhere, because you won't be able to reference that on the videos while you're watching this. So if you could take a second, go ahead and pause the video, copy the problems down, and then using these 2 ratios or these relationships, these special triangles, go ahead and try to find all the missing side lengths. All right, so now that we are unpaused, we're going to take a look at each of these and see how we can use the angle measures to find the missing side lengths. So in problem number 1 here, we have a 45-45-90 triangle. And in the previous videos, we talked about 45-45-90 triangles were also called, I'll shorthand here, isosceles right triangles. Isosceles triangles have at least 2 congruent sides. And so using some of our old theorems, we know that this angle and this angle are congruent because they're both 45 degrees. And if the 2 angles are congruent, then the sides that are across from them or opposite them are also congruent. So using our ratio over here on the right, we know that a 45-45-90 triangle has sides that are in a ratio of 1 to 1 to root 2. And so the first side we have is we have one of the legs, which goes here, which is 10, and that's one of our 1s. And so since this is 10, I know that the other side is also 10 because that's what an isosceles triangle is. And then to go from the legs to the hypotenuse in a 45-45-90 triangle, you need to multiply by root 2. And that is true for any 45-45-90 triangle. And so if we multiply 10 times root 2, 10 times root 2 is simply 10 root 2. Notice you cannot multiply these together because one number is inside the radical, the 2, and one number is outside. And these are your missing side lengths. So this is 10, this side is 10, and this side is 10 root 2. On number 2, we have a similar setup, but different ratios. We have a 30-60-90 triangle. So in this case, a 30-60-90 triangle using these top ratios are 1, let's go back there, 1 to root 3 to 2. And what that means is if you can find the smallest side of the 30-60-90 triangle, and the smallest side is always the side that's across from the 30-degree angle, which would be this guy. Once you find that, you can find the next larger side, which is the next longest leg, by multiplying the shortest side by root 3. And then you can also find the hypotenuse by multiplying by 2. So using that idea here, I'm actually not given this side, I'm given the longer of the 2 legs. And so this is 4 times the square root of 3. And so using this idea, you are able to multiply the shortest side by the square root of 3 to get the second longest leg. Well, we can also work the other direction. So if you are given the second longest side, which is the longer of the 2 legs, you can actually work backwards to find the shorter leg by dividing by root 3. So if you take 4 root 3 and you divide by root 3, this works out very nicely. The 2 root 3's cancel each other out, and you are left with 4. And 4 is actually the length of the shortest side, which is right here. And now that we have that, the only missing side we have is the hypotenuse, which is the longest side of a right triangle. And so to find that, you take the smallest of the legs, the 4, and you multiply that by 2. And again, the reason we do that, because that is the ratio. It's 1 to root 3 to 2. So if you have this smaller leg, you multiply it by 2 to get the hypotenuse. That is always true for a 30, 60, 90 triangle. So if we multiply this value 4 by 2, we get 8. And those are your answers. So the missing side lengths, we were already given 4 root 3. Number 2 is 4. And number 3 is 8. So the hypotenuse is 8. Moving on to numbers 3 and 4. Again, I'm going to ask you to pause the video and go ahead and write down these problems. Try them on your own. Again, the purpose of these is you're not able to use Pythagorean theorem because you don't have enough information. So what you're going to use is you're going to use these 30, 60, 90, and 45, 45, 90 ratios to try to find the missing information. And if you get stuck on these, that's fine. Just attempt them, and then we'll walk through them shortly. So go ahead and pause right now and jot them down. Okay, so if we look at number 3 now, this one appears like they did not provide us enough information because I don't have any angle measures for these 2 angles here and here, but they did provide us with tick marks. And those tick marks actually give us all the information we need. So if we go back to problem number 1, and I'm going to clear all the ink off this, we said that in a 45, 45, 90 triangle, it was really an isosceles right triangle. And so if the 2 angles are congruent to each other, then that means the 2 sides are congruent to each other. And so we can actually work the other direction and say, if the 2 sides are congruent to each other, then we know that the 2 angles are congruent to each other. So the angle that is across from this side is this angle here, and the angle that's across from this side is the angle here. And since those 2 sides are congruent to each other, I know that these 2 angles are equal. And then using some stuff from first semester and second semester, pretty much all throughout this year, we know that the 3 angles in a triangle add up to 180 degrees. We know that one of those 3 angles is a 90-degree angle. And so if we subtract that 90, we end up getting 90 degrees. And then the 2 remaining angles are congruent to each other. So if we take that 90 and we divide it by 2, we end up getting 45 degrees. So by putting the 2 tick marks there, that is another way for me to give you the fact that this is really a 45, 45, 90 triangle. And so since it is a 45, 45, 90 triangle, we know that the 3 sides are in a ratio of 1 to 1 to root 2. And now this one is slightly harder. So numbers 1 and 2 were meant to be not easy, but on the easier side. And so numbers 3 and 4, the difficulty is going to step up a little bit. So here, instead of providing you with the smaller of the 2 sides, which are the 1 and the 1, I actually gave you the hypotenuse. Normally in a 45, 45, 90 triangle, you're able to take either one of these 2 small sides, and then to find the hypotenuse, you multiply by root 2. We're actually going to need to work the other direction. So I provided you with the hypotenuse, which is this. And so if I want to work backwards to find the smaller sides, which we know are equal to each other, I actually have to divide by root 2. So we have 12 divided by root 2. Now, when I do this, we run into some issues. And I know this has been 3 to 4 weeks since we've done this. This was before break, before midterms. When you have a radical, and keep in mind a radical is just something that has a square root in it, you're not allowed to have radicals in the denominator. And so the way we fixed that, and by the way, if you want to try this on your own, go ahead and pause the video and then see if you can solve it. But the idea here is you multiply the top and the bottom of the fraction by the square root of 2. And what that does is on top, I get 12 times root 2, which is just 12 root 2. Again, you cannot multiply a number on the outside of a radical with a number on the inside. And then in the denominator, I have the square root of 2 times the square root of 2, which is the square root of 4, which ends up just being 2. And so now we fixed the problem where we no longer have the radical in the denominator, but we have some other stuff that we have to simplify. So if I leave the square root by itself because it is simplified, and I now look at the stuff that's outside, I have a simple division problem, 12 divided by 2, and 12 divided by 2 is 6. So my final answer here is 6 root 2. And that 6 root 2 is actually the measure of the two missing sides. So those are the ones. And so problem number 3 is complete. You have 6 root 2 and 6 root 2. On number 4, this is pretty straightforward, not as difficult as number 3. I give you the angle measures, 30, 60, and 90. And so we'll do this in a different color. So since it's a 30, 60, 90 triangle, we know that the three sides are in a ratio of 1 to root 3 to 2. And I provided you with a hypotenuse, so I actually gave you the 2, the longest side. So now going back to what we did on number 2, we said that if you know what the shortest side is, the side that's across from the 30-degree angle, you multiply that side by 2 to get the hypotenuse. Well, you can also work the opposite direction. If you're given the hypotenuse and you want to work backwards to find the shortest side, you divide by 2. So using that idea here, if I want to work backwards from 12 root 2 to find the shortest of the sides, which is this, I simply divide this by 2. And interestingly enough, we already had this particular number right here on number 3. We had 12 root 2 divided by 2, and we said that we can't touch the radical, but we can simplify the numbers that are out in front. So 12 root 2 divided by 2 is actually 6 root 2. So that 6 root 2 is the shortest of the three sides and the side across from the 30. Now, once we have that, to find the second leg, or the second longest side, I simply take that shortest leg and I multiply it by the square root of 3. And again, all these numbers are just memorizing the ratios. Every 30, 60, 90 triangle has sides that are in a ratio of 1 to root 3 to 2. And so if I multiply 6 root 2 times root 3, this is another example where you can only multiply numbers on the inside with other numbers on the inside and numbers that are on the outside with other numbers that are on the outside. Well, the square root of 3 does not have any numbers outside other than a 1. So if I do 6 times 1, I end up with 6. But then on the inside, I have the square root of 2 times the square root of 3, which gives me the square root of 6. And those are our missing sides. So the shortest of the three sides is 6 root 2, and I'm going to go ahead and slide this down so we can write it on there. 6 root 2. The second longest side is 6 root 6. And the third side is 12 root 2. All right, we're going to move on to the next two, and these are the hardest of the 6 problems. So similar to what we did on the first 4 problems, I'd like for you guys to go ahead and pause the video, copy these problems down, and attempt them on your own. And these are going to be tricky. So if you run into any difficulties, just wait and we will go through them. So go ahead and pause and copy them, please. Okay, looking at number 5. So number 5, pretty straightforward with how it's set up. They give us the 30 and the 60. So we know we're using the 30, 60, 90 ratios, which are 1 to root 3 to 2. Now this is one, what makes this difficult is if I give you the shortest of the 3 sides, this problem is pretty straightforward. If I give you the hypotenuse, this problem is slightly more difficult, but still pretty straightforward. But this is where things get a little more difficult. I'm not giving you the shortest side, and I'm not giving you the hypotenuse. I'm actually giving you the second longest side. So I'm actually giving you the root 3. So the problem here is this number 12 does not have a root 3. And so normally in a 30, 60, 90 triangle, you're supposed to take the smaller of the 2 legs and multiply it by root 3 to get the second longest one. Well, we're going to undo that. We're going to work the other direction. So to go from the second longest leg to the shortest leg, you actually have to divide by root 3. So we're going to take this number 12 and we're going to divide by root 3. And now we run into the same problem that we ran into on number 3 and on number 4. You are not allowed to have a square root in the denominator of a fraction. So we've got to fix that. And the way we fix that is the same way we fixed it earlier. You take 12 over the square root of 3, and you multiply the top and bottom, so the numerator and the denominator, by the square root of 3. Once you do that, in the numerator, you get 12 times root 3, which becomes 12 root 3. In the denominator, you get root 3 times root 3, which is root 9, and the square root of 9 is 3. And we have this part simplified, so the radical stays as is, and then we do 12 divided by 3, And so our final answer is 4 root 3. And so that 4 root 3 is actually the length of the shortest side, the shortest leg, which is this guy. And now we're in a good position where once I have the shortest leg, I then multiply that leg by 2 to get the hypotenuse. So I'm going to take that 4 root 3 and I'm going to multiply it by 2. And since the 2 is not inside the square root, I go ahead and multiply it out front. 4 times 2 is 8. And so the longest of the 3 sides, the hypotenuse is, is 8 root 3. And then number 6, we'll speed up a little bit because it uses the same idea here. It's a 45, 45, 90 triangle, same as earlier. If I give you the 2 tick marks, that tells me it's isosceles. So I know it's 45 and 45. And so that means I know that it's a ratio of 1 to root 2. And in this case, I gave you the hypotenuse, which is across from the right angle. So this is 6 root 3. Normally in a 45, 45, 90 triangle, you take the 2 smaller sides and you multiply by root 2 to get the hypotenuse. We're working the other direction. And so if I want to work backwards, I have to take that 6 root 3 and divide by root 2. And now we have a similar problem to what we had on number 5. I'm not allowed to have a radical in the denominator. So to fix that, I multiply the top and the bottom by the square root of 2. So in the numerator, I have 6 times a 1 because there's just a 1 out front, which gives me 6. And then root 3 times root 2 is root 6. And then in the denominator, I have the square root of 2 times the square root of 2, which is the square root of 4. And the square root of 4 is 2. And then looking at the numbers out front, 6 divided by 2 is 3. So my missing side is 6 root 3. And we actually have the answer to the problem now. That's 3 root 6. Sorry, I believe I said 6 root 3. It's 3 root 6. And now 3 root 6 is actually the missing side. And that is purely coincidence that the number out front and the number inside flipped. If this was, say, for example, 5 root 7, you would not just flip it and write it as 7 root 5. That was purely coincidence. And so our missing sides here are 3 root 6 and 3 root 6. So if you have any questions on these, we will discuss them further when we meet again next week.